could tell by your question that that's where your perspective was.
Yeah.
All right, let's go ahead and get started with our next speaker. Dr. Doss is with SGS North America. Dr. Doss is 40 years in the analytical chemistry arena, spans chemistry, environmental analysis, hydrocarbon chemistry, forensic industrial hygiene laboratory services, biota analyses, both traditional techniques and matrix solid phase dispersion, hazardous waste management, client services, management of laboratories, data validation, data management, laboratory audits, and litigation support. Dr. Doss received his JD from Southern University Law Center and was a law review editor. He earned his PhD in engineering from the University of Oklahoma, his master's in chemistry from Wichita State University, and his BS in chemistry from Loyola College at the University of Memphis.
Thank you.
Go ahead.
Thank you, folks. Welcome to the last topic of the morning. What I'm going to be talking about is from a lab perspective, and basically what is happening in terms of measurements, and I'll also fill in some of the gaps because there's a lot of questions about the data you're generating too, because of the lack of methods for non-drinking water parameters. So we'll go into it, and then what's happening in the regulatory aspect of it, and then go into the methods part of it on PFAS. So my thing is, if somebody is going to do a PFAS analysis, I would recommend a comprehensive set of analysis, because the feeling I have is, if you're going to go sample a site and collect certain samples and do a specific set of analysis and not do a comprehensive set, then you're going to go back to that same site to resample after the regulations kick in. So that's why you have to protect the interests of your clients and get a comprehensive set. I know there's lack of commercial laboratories as well who can do the comprehensive set, other than a couple of laboratories. So we'll go through it. As I go through my conversation, I'll fill it in. So my agenda is very, see if it's advancing though.
Apologies here. Technical glitch. There we go.
Yeah, okay, thank you. Yeah. My agenda is very simple. Background, and some of y'all have already covered the background part of it. Regulations and where we are and what's going on within the EPA. And then the analytical methods. Even in the analytical methods, there are several different things happening. The UCMR regulations, both the CCL4 or UCMR4 and UCMR5. And so what is covered in 4 and what is covered in 5 and all of that, and where they are at this point. And then the analytical methodologies part and conclusion. So what we have a privilege of at SGS is that we develop the methodologies for DoD and EPA, which is currently going through multi-lab validation by DoD and EPA. So you go through the method part, you give it to them, they go do the validation. Because if you look at any regulatory scheme, depending on the use of a method, you have to go through a certain set of validation processes. So if you have just drinking water, or if you're going to modify a method even. So you have a wastewater treatment plant, it's defined. So based on your waste, you can go modify a method, and EPA will allow you to do so for that specific operation. But when it becomes universal, a minimum of 9 laboratories need to participate in your validation study. So there's a lot of rules embedded within the validation aspects of a method. And they have tier 1, tier 2, tier 3 programs on it. Background, it's plural because you have the per and the polyfluorinated alkylated substances. There's about 4,000 to 6,000 of these PFAS components. So you'll see in the next couple of slides how it came up with such a large number. And then back in the 1930s is when the chemistry came into being on PFAS, but actually manufacturing went in 1948 or around 1950. And also what you need to know is the carbon-fluorine bond is the strongest bond you'll encounter, so destruction is going to be tough. So what surprised me on this aspect of it is I started up in dioxins. I have a Burger King hat as a dioxin king with burger removed in it and dioxin filled in. So when I started, there was no criteria even for ratios on dioxins, dibenzofurans. We developed it first, submitted data on a CLP SAS program. 6 months later, they used those ratios to fill in with the methodologies. Is how it worked. So in terms of chlorine carbon bonds, incineration is about 1100 to 1300 degrees C for the chlorine or the dioxins to be destroyed. And I was wondering why 900 degrees C was used for a chlorine-fluorine bond. I know the retention times and all of those things, but Japanese had already done 1300 degrees C for destruction on thermal aspects of it. So that's a perspective which I have, and I still wonder. So the research, and they're back into research trying to figure out how to do the thermal destruction part. And there were a couple of instances in New Jersey and New York which stopped that process in a commercial way, and back to the drawing board. And then PFAS as surfactants. So what happens is if you work in a nuclear industry and you're wearing a lab coat, and they go to a specific laundry location, and there the final part of it in the laundering process is adding repellents so that none of the radioactive materials stick onto your coats is how all that works. So it's omnipresent in carpets, couches, products like containers coated, and then Teflon pans, all of those things. So that's why it's forever, but I also call it everywhere. And it's not just in one location or another. So, and the chemistries are very complex. So basically, this is how it looks like on a PFAS component. And you have the green balls and the colored ones. The colored ones are the functional groups, and the greens are the carbon-fluorine bonds, which make up the PFAS compounds. And there are various lengths, octanoic, decanoic, nononoic. And also what has happened is, in a couple of instances, groundwater plumes have been contaminated in New Jersey, where they never even expected it. Because it's part of the manufacturing process is how PFNA got into groundwater plumes. And they didn't even bargain for those components is what has happened. So there's a variety of chemistries, and there's still unknowns. That's why you need to do a comprehensive set of analysis. Also, terminology part. Yeah, you have to be running these standards every day to remember what the acronyms are. But typically when you get a lab report, it'll be all defined for you. And then the production methods, earlier speakers have gone through it. It's electrochemical fluorination and telomerization are the two processes to make PFAS. There's a lot of list of compounds, but like I said, when you go to lab, they'll give it to you. And again, PFAS, there's non-polymers and polymers on the classification part of it. And then within that, you have the per and the polyfluorinateds, and then the telomere part of it on the alcohols. So some of it, like the previous talks, you get biotransformation on some. Even that is uncertain. There's some literature published, both in the ITRC documentation, Colorado School of Mines, and University of Washington, but don't take it for granted because there's a lot of unknown things going on in that. So that's in a network, in a general sense on the classification part of it and the family tree. Like I said, there's about 4,000 to 6,000 compounds, right? So we have to be careful on what you have and what you don't have. So basically, persistence is the big issue. Biodegradation is not done, although I have seen some papers from Asia where they claim certain bacteria do break it down, but the confirmation part of it is not available at this point in the literature. So that's what's going on and why it's called forever chemicals and everywhere. Like the previous speaker said, it started with PFOA and PFOS, and then it went on to multiple components, and then it became fluorotelomers, all of those guys, and then all the rest of the PFAS. So that's what accounts for everything. So in the regulatory world, initially it started off like the EPA health advisory limits are just the two compounds, PFOA and PFOS. And then now with the drinking water part of it, 537 versus 537.1 versus 533. So there's a lot of different sets of components. So when you even analyze for drinking water, you need to be sure you get a comprehensive list of compounds analyzed for. So that way you don't miss any one of those in that, because that part is set in terms of methodologies. But the rest of the world and the rest of the matrices is a different story. And then regulations, like I said, the health advisory limit is 70 ppt, and not all states are equal anymore, because since EPA hasn't acted yet on the regulatory aspect of it, the states took the lead and went on with their own limits. There's a table I'll show you, and the limits are far lower than the 70 ppt on a combination of compounds. It's not an individual compound. So, and then the TSCA rules, the SNOR part of it, the TRI is part of the NDAA. So the National Defense Authorization Act, which was passed in end of 2019, went into being January 1st, 2020. And the first reporting on the TRI happened on July 1st, 2021 for the year 2020. And it's going to continue till everybody finds everything they have, or even if it's reportable because of the quantities. And then CERCLA, we don't know what they're going to do, but don't get me wrong, because anytime you endanger health, life, and the environment under the constitutional privileges, then EPA can act on it, any compound for that matter, if it affects those things. So, and then Clean Air Act too. So, and we still don't know what's going on in there as well. States have taken control and lead based on, and some of the states are still sitting at 70 ppt based on the health advisory limits, and some of them have gone way low, like California is the lowest of all of the states. So there's a saying in law school, as go the land of fruits and nuts, so go the rest of the nation. Whether it's criminal law, environmental law, it doesn't matter. So anytime we review case law in law school, I have a law degree too, and I'm a licensed attorney in Louisiana. So first thing is the law professor will ask, which circuit did this case stem from? And invariably in any criminal law, it's circuit 9, so which is California is what happens. So that's why they are the leading people in setting limits for components. So I don't know where it's going to end up. Even when dioxin started, that was the most dangerous chemical known to man. That started in the PPP level. And here we are in the PPT level. And so that makes it even more complex in measurements. We started with a low resolution method there and then moved on into high res. And now we are back into triple quad. In fact, our lab developed that method and EPA approved it about a couple of months ago, doing dioxins by triple quad. But here we are starting with the triple quad with an LC front end to it instead of a GC front end. The levels are very low to go with, and then the majority of the PFAS stem from firefighting in bulk quantities. So that's where most of the uses were. And then as people became aware of the chemistry part and what uses it had, then it predominated in all of the daily uses. We use PFAS as repellents. So that's how that goes. And basically, Congress passed the House passed it, and the Senate is yet to act on it on EPA, and this happened in July of this year in House Bill 2467. So we don't know what's going to happen still because everything is not in an even playing field currently. NPDES is a different story. So what has happened is EPA published last year that over this year, they're going to do things and then incorporate PFAS into the NPDES permits, right? So actually, I know several facilities where PFAS is part of the monitoring program currently, even though there are no limits. So and wherever there was primacy by EPA, they've gone ahead and done it, and they're just monitoring at this point. And predominantly, it's more in the refining arena because they fight a lot of fires, and they have PFAS foam sitting on their sites, and they're waiting to dispose because there's no thermal destruction, and they don't want to take a chance because once you created that waste, then you're going to gain ownership no matter which landfill or whatever does things to it. So what has happened is the reason why the NPDES program has not gone into effect is methodology. Because other than drinking water, you don't have any methods promulgated for non-drinking water matrices. So wastewater disposal and treatment part on the effluent guidelines part comes under the Clean Water Act and not the Safe Drinking Water Act. So you have to wait till methods come in, but they've already included in it because if you look at what happened was 2 weeks ago, that I think I'm getting ahead of myself. Let me refrain myself, come back to it. So that's why NPDES program hasn't kicked off officially with a limit, is because there's no methods. And then I'm going to talk about the UCMR a little bit because 2013 through 2016, because I did the statistics for API on all the drinking water parameters and also the PFAS data which they collected during that time frame, and where they found PFAS components in drinking water. So UCMR, what happens is every 5 years, EPA looks at what they're going to be regulating in terms of components. And UCMR 4, they listed only PFOA and PFOS as the only 2 compounds to be regulated. And that regulation is not out yet. It should have been out by January this year. That didn't happen. So for some reason, they're holding back on it. And it could be the methodology part of it. So UCMR 5, so they've listed a whole bunch of compounds. And then PFAS has 29 of them. So where does that come from? It's because of the drinking water method in 533. That's the magic number, 29 compounds listed in it. between 537.1 and 533 that make up the 29 compounds. So that's what's going on in, but UCMR5 is about 3 years away from getting to a finishing point, but UCMR4 is completed, but that hasn't triggered the regulation yet. Air part of it, there are a couple of states which have gone ahead with it. Michigan has a 24-hour average of 70 ppt, and New York for PFOA alone at 53. So that's what's going on in the air world, and still methods are all over the map on air part. Yeah, the MAC studies are being conducted, all of those things. I used to be part of Test America, the network part of it before Europeans bought us. So there we did MAC studies for emissions, and they're working with the EPA on PFAS even, is what's going on. States, a lot of the states listed on here are regulating PFAS, and they have their own limits. You'll see the limits on the next slide. And the issue here is you just cannot just analyze for those components, because there are precursors attached in the manufacturing processes. If you don't break it down with a top assay, then you won't even see it. Example, I have some slides on AFFF foam. It's day and night difference. You may not even see anything in it. All of a sudden, you do the top assay, it's bigger than dollars. Leave alone compounds which are present, which are like 300% higher than what you saw in your original analysis. So those are the state lists and what they're doing, but we'll go to this. This is a table which I created while at Environmental Standards, just to give you a list of components and which state has what limits. So I know the slide is not that very visible, but it's a comprehensive list is what it is. And if you want to see it, if you go to the Environmental Standards website, then you'll go to the PFAS page on there. It'll be right on the front page. You can look at it, and you can make a copy of it there as well. So they keep it updated, is what happens as the limits come up for different states. What's next in the regulations? Basically, the NPDES will definitely go into effect this year sometime, because the methods are not far away from being validated and put into vogue. So it's maybe, I would say, in fall this year is what will happen. So that's why there's a lot of these things in flux. And so we don't know until it happens, hopefully fall. And then methods part of it, like I said, 537.1, 533. 537.1 is a modification of 537, which was the original method for PFAS, which has been in the books for a long time. But it wasn't an isotope dilution method. So what people do in the laboratory community is take 537.1, even though it's a drinking water method, and then do the isotope dilution part of it and use the SPE cartridges for extractions. So, and each one has a slight mark to it. So I had the privilege of auditing labs. So when you ask for the SOPs, it'll all be redacted. So once you go into the site, then show me how you go through your extractions process. That's when you learn what it is, but you have a non-disclosure. So as an auditor, you need to be careful what you say and don't say. But I can tell you that a lot of the labs have redacted certain things which they use internally within the thing. And that's what makes the variability. So I call it labs are making up their own methods. So that's how I stated, if I was a consultant or environmental standards, that's what I would say. So, and then what happened was this 8327 method was a draft method until 2 weeks ago. So EPA put out a method because of a lot of pressures for the non-drinking water method. And now they published it in SW846 and then went on to describe that it is a guidance document. And so labs, and if you go to the website where this is cited, they go on to say that as long as the QA/QC criteria are met, you can use this method to run PFASs for regulatory purposes, is how they're saying, because there's no other method available currently. And this is a copy of ASTM D7979 as well. It's part of the D1906 committee. So that's what happened 2 weeks ago on 8327 becoming an official method in SW846. And this is part of the EPA NEMC conference. It was announced the day before the conference started because EPA was going to talk about it at that NEMC conference. So that's what has happened. So you need to be aware of that part of it. And then the upcoming part, the 1600 series method, what that is our lab in Canada did the method development for 1600 series method and delivered it to EPA and DOD. So they are going in and taking this method and doing a multi-lab validation to fulfill all the regulatory requirements to make a method official. So that's not too far off. It's coming up in a month or two is what I would say. And then ASTM methods are available, 7968 and 7977, 79. And this has been in the ASTM book. So what this is EPA is part of these two work groups in D1906, because I'm part of the ASTM D1906 DO2 committees as well. So they introduced it because of the bureaucracy at EPA that they cannot get a method through. So that's what's happening. And same way you thought that PFAS was a big monster, wait till you encounter microplastics. It's huge. It'll dwarf PFASs is what will happen. And methods are being developed again. EPA is putting it through ASTM for those destructive and non-destructive methodologies as well. So this is a big chart in here. And basically drinking water is defined. Non-potable water is in flux, but what has happened is 8327 got into it. And then in 1600 series, so SES Access has done that, handed it over to DOD EPA, and that's what they're going through the validation with. So that's in a nutshell what you have. And AIR has various options. We'll go into detail in another slide. So this is what we did. We did a phase 1, then the phase 2, and then EPA needs to publish it at this point as SES Access, and the multi-lab validation is ongoing currently. Or it's actually done. They're analyzing the data. Accreditation-wise, it's also depending on which state you are in. Some accredit, some don't. In fact, one of my issues with California, when they brought in all these low levels, is that they were grandfathering labs into the program. So if you looked at it, when they initially introduced the PFAS public comment requirements part, I said you cannot be grandfathering when there's PT samples available in the market. You need to be requiring PT samples of lab. So what they did was they pulled back the whole document and then went with a NELAC approach, and that's what's currently being enforced in California, is how that works. So this is how the map looks like on accreditation, and it's always changing too. So as a lab, you need to be on top of things as things are happening too. What's new at SGS? Basically the 1600 series methods, and then we do the stack testing part of it on OTM 45. Those are the impinge methods. We'll get into it later. And then ambient air testing using TO9 is what we're doing. And then our different laboratories which do different things. SGS Access is the technical arm or the most sophisticated technical arm. Everybody has technical capabilities and experiences, but these are our three labs which perform PFAS analysis. Like I said, we were pioneers in doing this, so we have advantages to it because we can run fish tissue, any type of matrix, and I have a lot of case studies, but it'll take me a long time to go through. I pulled it out where we worked with different treatment technologies with different people, and we have data for all of those things to show as well. And one thing, folks, the reason I talk about comprehensive analysis is you'll be shooting yourself in your foot if you don't do the comprehensive analysis, even for surface water and groundwater. The top assay is very important because you'll miss a lot of compounds when we go into litigation. It's a big issue to determine whose PFAS it is or who contributed to it. PFAS supported, basically these are the standards available in the methods, but another caveat here is standards are not available for all PFAS compounds. Currently, the total you can buy in the commercial market is about 75 compounds as standards to really quantitative. Best practices, basically the multi-matrix part of it with LC-MS approach. And when you go into forensics, I'll go through it, a couple of slides on that. So basically what you need to do is look at contamination, just like for sampling. We wrote a couple of sampling manuals for different clients and how to go about avoiding contamination. Yeah, there are general documents, but you need to look at your circumstances because when you go into a plant or a refinery, what happens is they wear fire retardant clothing, right? You cannot be using fire retardant clothing and then go in and sample PFAS. So you need to watch out what you do. So you need to get exceptions from the safety guys within that plant. So that way you can wear different type of clothing and not use certain types of things when you sample, so you introduce contamination into it. And then on the technical side, what you need to look at is the transition ions. So typically, if it's a parent and a daughter ion, you probably want to add a third conformation ion in single ion monitoring. And also, you need to establish your ratio criteria, just like the dioxins have, but I haven't seen any other method which prescribe ratio criteria for single ion monitoring. And all of this happens in single ion monitoring. But if you're running a full scan mode, you don't need that because you got a full spectrum. And even there, I would look at what happens with the ratios, because now it's not a DFTPP or a BFP tune in your normal world where it's well defined. So you have to be careful because the spectrum produced by Test America in California versus Test America in Burlington may not be the same. So that's where when you go through the lab data, you need to be careful on how you evaluate it. And then you have to look at linear and branch chain isomers too, because that'll make a difference in how you go through the forensics aspect or determine whose PFAS it is. And then sample prep, you have to have the cleanliness. And then sample bottles is another thing too. So, and when you use your Teflon tubing in your balers to collect groundwater, you need to rethink that process. And also the O-rings you put on your pumps, you'll have to look at that also. And this is a picture of how the LC-MS system works. Like I said, triple quad Q1, Q2, Q3. And Q2 is used as a collision cell instead of further filtering the masses. And that's where you break it down from the parent ion from Q1 and then the daughter ion on Q3. So that's the process used to identify PFAS. Then isotope dilution is a key. do not go with the water direct injection part because the recoveries won't work right. And also a lot of the labs cannot handle regular straight analysis. Isotope dilution is a must, is what I would say. Then clean up part of it. This is the cartridges we use to go through and extract the PFAS components and elute it off of the cartridges. Then use multiple transitions, like I said, so you have confirmatory components in it. Then linear versus branch chain. I think one of y'all touched upon it already. And basically that's that'll determine source identifications in your conversation about it on the percent of the different components. And also you have to rinse the whole bottle, folks. This is what we found out through our research. And so get the sample size required and rinse the bottle so it doesn't adhere to the walls of the plastic container or HDPE. And so a whole sample would be better, so you can rinse it out with methanol, so you account for all the PFAS components. And again, extraction, cleanup, CMS, MS part of it, and going through that aspect of it. And then sampling methods for error. There are a variety of combinations of methods depending on your application. So the OTM 45, which exists as the Impinja method, is what it is, which is traditional for air emissions on a stack test, is how we do it. And it's a long-standing thing on Impinja solutions part of it. Yeah, there's continuous monitors, but for quantification and all that, they do this. And then fingerprinting part. So there's a long list of analytes, right? So the way I would approach it is use your standard method, do the top assay, and run the NTA part. I know the commercial lab-wise, as far as I know, based on some of the experiments I've set up for clients, is that there's about 3 labs in the US who offers QTOF HRMS in the high resolution mode. So in the high resolution mode, you get the full scan, and then you take that. No lab can process that data for you. So you'll have to seek expertise in order to go through and do the NTA analysis and do the comprehensive non-targeted compounds. It's just like tentatively identified compounds in your volatiles and semis. That's what non-targeted analysis is. There, it's very simple because you got the NIST library of 44,000 compounds. Here, EPA has a database, and it has 875,000 compounds in that database. So the chances of you doing a comprehensive analysis is very good on PFAS to account for the 4,000 to 6,000. You may not have all of those in your sample, but at least whatever you see, you got it identified. And that's the high resolution QTOF part of it. And some people do high resolution QTOF with a GC MSMS part of it instead of an LC MSMS part. So top shows significant non-target PFAS at AFFF sites. This is the day and night difference I talk about. So basically, you can see some compounds which didn't exist in your initial analysis all of a sudden show up. Like a 300% increase is typical of what you would see between regular versus top assays. And here's an example. Look at all the orange bars, and they are after the top assay. And the gray ones are the regular sample analysis. So look at it, what's happening in there. Compounds which didn't show up in your regular analysis because you don't have many gray bars, all of a sudden show up bigger than Dallas, what I call it. So that's why you have to, and EPA has to address top assays if they're going to hold regulated community accountable for the contamination. Positives on the top assay, like I said, each one makes up their own method. So that's what you have to look at. So you have to work out all the details and how you design. You can do it. If you're sophisticated enough, you can define it for the lab and for your client and obtain the right set of data. AFFF products, like I said, we developed the method for it, both for the AFFF and ARFFF. So the AR is alcohol resistant FFF, and AFFF is aqueous. Linear versus branch chain, you definitely need that if you're going to go battle. So all of the methods ask you to report both the linear and the branch chain. And this is a new topic. The first method is going through ASTM currently, and that's the combustion ion chromatography. So what happens is you run it just like your fluoride analysis in your regular water sample, but here you combust it to break it up, and that way you measure the fluorine content completely in your matrix. So what this does is gives you a picture, basically, to go forward or no. But the numbers don't correlate exactly. So typically, for example, if you spike a sample with AFFF or PFAS compounds, and then go through this combustion IC, typically the IC values are 50% greater than your regular total analysis you see. So, and also another caveat is that the detection levels of TOF is much higher, the detection limits are much higher than what you see in the parts per trillion part of it. So it's a hit or miss on the screening part, unless somebody can make an instrument which will measure to the parts per trillion level. So that's what you need to be aware of. But ASTM method is almost there for ballot. And there's EPA method coming up where they're going to validate it on their own for combustion IC. It's a good technique if you have a lot of like AFFF sites. It's very good for screening to see if you want to move forward or not. And what happened was we started a committee at the Marcellus Shale Coalition for the hydraulic fracturing folks. So the initial thing was, oh, we don't have any PFAS components in our matrix when we injected to do the hydraulic fracturing. But guess what, folks? In 2011, EPA has that data, because all those are polymers which go in to slick the formation when you inject and fracture. They call it slicking, is what it is, and all that is long chain polymers, some are fluorinated. So obviously you're going to have PFAS, and the reason for that is even though it's a long chain polymer, you can form PFAS because of the temperature conditions and the pressure conditions downhole in the formation. Some of them are like 280 degrees C on the temperature part, and the pressures are 9 to 10,000 pounds. So, and then the pressure you exert when you inject the fluid for the fracturing aspects of it, all that makes a difference. And so people really need to look at the hydraulic fracturing chemicals and what they put in to look at the possibilities of PFAS in that. Non-targeted analysis, again, like I said, there are a few labs who do it. So you need to take advantage of that if you can. It's not that expensive for the analysis part of it. People can afford it to safeguard their interests in a battle in litigation or with EPA even. So conclusions, complex analytical protocols, promulgated methods do not exist other than for drinking water. Data comparability as it exists today, it's very tough to do that from lab to lab. So unless you define your parameters, knowing the chemistry aspects and the instrumentation aspect of it. And then calibration compounds, that's a big issue because standards are not available for everything. Yeah, TRI is 172 compounds, but maximum you can have is about 75 compounds as standards to quantify it. And then litigation, cover all possibilities, validate the data. Okay, that's another big issue. So here you get a piece of data, right? You better validate that data. Go through the calculations from scratch. I can tell you from experience, it's not the same what you get. And specifically for AFFF foam, because of all of these serial dilutions, a lot of steps get missed and it's not documented. So you need to watch out. Your final numbers may be totally different from what the report said. So you definitely have to do the data validation on it and take care of it in that light. And then very little expert in the commercial expertise in the commercial sector on NPA, but there are people who do it and research institutions do it as well, take advantage of it. And then regulated communities still uncertain as to what data they need. So that's where consultants, chemists all get together and do the right things for the clients and for the regulated community. All I have, folks, and that's my contact information. And if y'all need any help, like I said, I've been around for a while. And like my first sampling job was in Guthrie, Oklahoma, back in 1979. So I call it, I have a lot of technical BS behind